Well, I guess we're live, are we? Well, hello guys, welcome. So before we start off today's class about capacitors, थोड़ा एक बात बता दे. Hello guys, welcome. I want all of you guys to keep your distance, maintain social distancing जैसे कि ये लोग कर रहे हैं. Maintain social distancing, stay at home, stay safe. I know this is tough time for all of you, but that is why we are here to help you. I am here to help you with classes online, free classes. Keep your distance, stay at home and stay safe. All right, so install the crack IIT-JEE with India's largest platform, which is Unacademy. Undoubtedly get the plus subscription and access unlimited live and recorded sessions from India's best educators. From India's best educators you can get unlimited live and recorded sessions. Hello Sim24, welcome, right on time as usual. So Unacademy app, install this app right away. This is very pretty cool, like you have all cool stuff here, all free quizzes, free classes, सब मिलते हैं यहाँ पे. And you can also take the subscription here to access. About me, hola amigos, I am N Srikant. I did my BTech from IIT Kharagpur with an IR of 385. I've been guiding young minds for the last 4 years. You guys human calculator. You guys call me human calculator, and I am a Sunrisers fan. All right, I know it is tough time right now, but then yeah, it is what it is. And DC is equally marvelous, if not better. All right, I'm a DC fan. मतलब कुछ भी opinion है तो feel free to comment in the comment section below. And this is the program I've launched for you guys. It is called Ad Astra. Crack IIT-JEE with India's largest platform. So it is Ad Astra. The meaning of Ad Astra is it is aiming for the stars and cracking IIT-JEE. All right. So that is about it, guys. So this today's topic is capacitors number 2. This is chapter 2. आज chapter 2 चल रहा है, where we will discuss about parallel plate capacitors and much more. This diagram is a symbol of capacitance because this is only corona discharge. तो ये corona discharge के बारे में थोड़ा बात करने के लिए I put it here. So before we go further today, the main topic we'll be discussing today is about dielectrics. Okay, we will be discussing about dielectrics introduction. तो कल जैसे हम डिस्कस किए कि कैसे चार्ज यहाँ से यहाँ जाता है, उसके हिसाब से मोर चार्ज गोस द मोर पोटेंशियल डिफरेंस विल हैपन, स्लोअर दिस पार्टिकल्स विल मूव. ये सब लॉजिक कल हम डिस्कस किए हैं. टुडे वी विल डिस्कस अबाउट डाइलेक्ट्रिक्स. सो व्हाट हैपेंस नॉर्मली व्हेन देयर इज एयर हियर, व्हेन देयर इज अ नॉर्मल कैपेसिटर विद एयर, इट इज जस्ट लाइक दिस. Okay, with air or vacuum there will be plus charge here and there will be minus charge here. Okay, there will be no polarization in between. But if you introduce a dielectric here, dielectric will give you polarized molecules, जिसके कारण यहाँ पे थोड़ा डेल्टा नेगेटिव हो जाता है और यहाँ पे थोड़ा डेल्टा पॉजिटिव हो जाता है. Because even the electric field will also orient. Hello Sairam garu, hello ma. Okay, so the orientation of the electrons, the molecules will change such that the negative charges will come closer to this and positive charges will come closer to this. As a result of it, there is also some extra field inside. Extra field ये सब होते हैं. So we will discuss about all of those things today, guys. In a great session today, we will discuss about how dielectrics impact a capacitor, what happens to capacitance, what happens to the charge on a capacitor, what happened to the potential difference between a capacitor. All those things we'll be discussing in today's wonderful class about capacitances. So equivalent capacitors 2, this is the, we will be continuing with the problems on total capacitance जो हम कल कर रहे थे. We were in middle of it, so we had other exciting problems which we could give. So that we will be doing today. And not only that, we'll have an introduction to dielectrics. जैसे कि मैं अब just introduce किया आपको, I will use the same. We'll understand in-depth analysis of it. Like we'll understand how to calculate problems कैसे करते हैं. ठीक है, and we'll also do analysis of dielectric, where what is the energy stored, dielectric के कारण कितना energy बढ़ता है कि घटता है, ये सब हम let's find out. All right. So in this question, this is the first kind of question. This question is very important because ये बहुत analytical है. I've given this question because it is very analytical. So we want to find the given each capacitance plate has area A and separation of D. फाइंड द इक्विवेलेंट कैपेसिटेंस बिटवीन 1 and 2, ये दोनों के बीच का इक्वल कैपेसिटेंस। अब ये समझ लो, when you have parallel plates, one parallel to the other, parallel to the other, each one of them together will form one capacitance, right? A will form capacitance with B, A will form capacitance with D, with B, C will form capacitance, B will form capacitance with D and also with A. इस तरह जो बगल बगल वाले प्लेट्स है, we can all call them to be single capacitors. All right, so what I will do is I will take this point A here, इसको बस कैपेसिटेंस इक्विवेलेंट कैपेसिटेंस में ड्रॉ करना है. वी हैव टू ड्रॉ इट इन टर्म्स ऑफ इक्विवेलेंट इक्विवेलेंट कैपेसिटेंस हमें फाइंड आउट करना है इसका. तो फॉर दिस वी हैव टू ड्रॉ द करेक्ट डायग्राम. ऑलराइट, वी हैव टू फाइंड पोटेंशियल अक्रॉस कैपेसिटेंस अक्रॉस A and B. So from A, let's draw one capacitor which is connecting directly to B. ठीक है, एक कैपेसिटेंस A और B के बीच में सीधा है. Alright, and there is one between A and C. If you observe, there is one between A and C which is equal, and there is also one between B and D. Okay, now we know C and D are connected by a wire. So ठीक है, यहाँ पे D मान लो. So this is how we draw it. Are you able to understand this? This is great. This is a very simple concept and great way to understand it. इन दोनों के बीच का एक कैपेसिटेंस है, इन दोनों के बीच का कैपेसिटेंस है, इन दोनों के बीच का कैपेसिटेंस. So A and C we drew one capacitance which is C1, A and B we drew a capacitance which is C2, and B and D we drew a capacitance which is C3. Is it clear, guys? Everyone? I want to make it perfectly clear. Just the alternate plates. That's all. So plate bagal bagal mein we make them into one capacitor. So this is how we will end up making it. And we know C1 will be equal to C2 will be equal to C3 will be equal to epsilon naught into A by D given by all this given factors. इसको सीधा अपना लेते हैं. Now what is this? What is the condition for this? C2 is in parallel with C1 which is in series with C3, right? This is how we solve it. So C2 is in parallel with C1 C3 by C1 plus C3. Because series है, series का sum कितना है? C1 C3 by C1 plus C3. So this we will apply, we'll get C1 C2 plus C1 C3 by 1 plus C3. This is the equivalent capacitance, and we know each of them is equal to C. We'll call this as C. तो इसको क्या हो जाएगा? तो C equivalent हो जाएगा C plus C square by 2C, which is eventually coming out to 3C by 2, which is nothing but 3 epsilon naught A by 2D. Wonderful solution, guys. एकदम simple हो गया. So is this clear to everyone? Yes, this is the wonderful explanation we have here. तो यहाँ पे क्या करे हैं? So we drew the capacitances based on which plate is facing which plate. All the plates, adjacent plates which face each other form a capacitance. Because capacitor is nothing but capacitor itself is a plate. तो दो plates है तो दो plates मिला के parallel plate capacitor बन जाएगा. Any two parallel plates together will form one parallel plate capacitor. So this is the solution, guys. So are we clear? All right, great. Now let's go to the next question. तो मस्त है. Find the C equation between C equivalent between the two plates as shown. यहाँ पे तीन प्लेट ऐसे लगे हुए हैं. Everywhere the area is split into A by 3. Yes, thank you Sim24. The area between the two plates will be A by 3 each. Getting it? And there are three plates with different separations. तो इसका इक्विवेलेंट कैपेसिटेंस निकालना है. ये कितना होगा? ये ऑप्शन है आपके पास. आई एम गोइंग टू गिव यू टाइमर, गाइस. एक मिनट रुको. ऑल राइट, आपके सामने टाइमर है. इट स्टार्ट्स नाउ. लिख दिया. ओके, आई एम गोइंग टू गिव यू 1 minute फॉर दिस. कम ऑन। तो इसमें सिंपल है, देयर आर 3 कैपेसिटेंसेस, तीनों एक के सामने एक है, तो इफ यू ड्रॉ द इक्विवेलेंट फॉर दिस यू विल गेट 3 पैरेलल कैपेसिटर्स। यार इस क्वेश्चन में एक स्पेशलिटी है, देयर इज अ स्पेशलिटी अबाउट दिस क्वेश्चन वेयर you can solve it without even solving it, you can just see the question and just get the answer. There's a very nice trick to it, so I'll be telling that trick also now. एक मिनट बच गया, so let's get starting. All right, तो इसमें देखो, how does this work? Let me tell you how this works. All right, some problem with the writing, guys. Thank you Anuradha, welcome. All right, so there's some small issue with the system here, ये stuck हो गया। गुड टू गो अगेन, ठीक है, एक मिनट। तो दिस क्वेश्चन वी आर बैक गाइस। तो अब इसमें देखते हैं क्या होगा, व्हाट इज हैपनिंग हियर। देयर आर 3 कैपेसिटेंसेस हियर, वन इज लाइक दिस, वन इज लाइक दिस एंड वन इज लाइक दिस। बस वही है ना, द 3 कैपेसिटेंस लाइक दिस, इफ यू लुक एट देम सेपरेटली देयर लाइक 3 ऑफ देम ऑल कनेक्टेड बाय द सेम wire, so which by this we can say these are all 3 capacitances in parallel. यहाँ से we can say this will be C1, ये C2 है, ये C3 है, and C equivalent will be equal to C1 plus C2 plus C3. That's it, guys. Ramesh, Ramesh is one of my fans on the quiz show. All right. No, आज नहीं है. We'll have it tomorrow. All right. So C1 is how much? Generally, capacitance is given by epsilon naught A by D, right? Capacitance is given by this formula. So C1 value will be equal to epsilon naught into A by C2 now. C2 will be equal to epsilon naught into A by 3 into 2D. No, the separation between these two plates will be 2D now. ये separation 2D है, तो यहाँ पे 2D हो गया. And C3 will be equal to epsilon naught into A by 3 E by 3D. अब सबको ऐड कर लो. Is epsilon naught A by D common 1 by 3 plus 1 by 6 plus 1 by 9. That's it. तो एकदम 18 कॉमन डिनोमिनेटर, 9 ही कॉमन डिनोमिनेटर ले सकते हैं। हाँ नहीं, 18 का ही लेना है ना, 16 नहीं है। 18 कॉमन डिनोमिनेटर ले लो, ये हो गया 6 प्लस 3 प्लस 2, तो टोटल कितना हुआ 11 एप्सिलॉन नॉट ए बाय 18d, व्हिच इज द आंसर गाइस। सो वी गॉट द आंसर, एकदम सिंपल हो गया ना। When they are connected like this, you can take them to be in parallel. Got it? They are not in series, they are in parallel. So this is one of these wonderful questions we are going to solve. All right, now three uncharged capacitors having capacitors C1, C2, C3 are connected as shown in the figure to one another at the point A, B, C at potentials V1, V2 and V3. इसका potential V1 है, इसका V2 है, इसका V3 है. Now the question is the potential at this thing will be how much? Now this is a very interesting question, guys. I'm going to give you a timer for this now. Yes, I will give you a timer. Don't worry. Okay, the timer starts now. Hello, Subhashri Pothal. Welcome. Good evening. Very good evening, guys. Very good evening, Ramesh and Sim24 and Anuradha Chandi. Welcome. Just let's have fun. So इसमें we have to use the nodal analysis. We generally जैसे हम discuss किए थे nodal analysis का, and when three plates are connected by the same wire, what happens there? So we have to use both of them together and we will get a very wonderful answer here. Yes guys, so this is the question. 1 मिनट बच गया और कोई आंसर नहीं दे रहे हैं. शुभश्री, इज सी द करेक्ट आंसर? वेल, मैं एक बात बताता हूँ, ये सिमेट्री से तो नहीं लग रहा है. इवन आई डोंट नो द आंसर. द फ्रैंक पॉइंट इज इवन आई डोंट नो द आंसर. आई वाज वेटिंग फॉर यू गाइस टू टेल इट. हो सकता है सी करेक्ट है, पर सिमेट्री के हिसाब से देखा जाए. वी हैव टू सी इट फ्रॉम द सिमेट्री पर्सपेक्टिव. ऑलराइट, सो लेट्स स्टार्ट सॉल्विंग. इसका पोटेंशियल बी ले लो. तो क्या हुआ, यहाँ पे Q1 चार्ज ले लिए, यहाँ पे Q2 ले लिए और यहाँ पे Q3 ले लिए. V1, V2 and V3. And what do we know about them? We know one thing, Q1 plus Q2 plus Q3 should be equal to 0, क्योंकि ये तीनों एक जगह में है. The entire this in this close, if you take this Gaussian surface, or if you take this, if you take this Gaussian surface, there is no charge there but field sub here. So adding all this together will come out to be 0. Getting it? So this is the first equation we will get, and then we will also gradually write potential in terms of everything. Q is equal to CV, right? Q is equal to C into potential difference. So let's write off each individual equation. Q1 will be equal to C1 into V minus V1. अब Q2 कितना हुआ? C2 into V minus V2. और Q3 कितना हुआ? C into V minus V3, क्योंकि ये पोटेंशियल डिफरेंस है अक्रॉस. तो इसको सबको ऐड कर दो. वी गेट C1V minus C1V1 plus C2V minus C2V2 plus C3V minus C3V3 is equal to 0. जैसे कि मैं बोला, सिमेट्री से we will get C1 plus C2 plus C3 into V is equal to C1V1 plus C2V2 plus C3V3. इससे आ जाएगा आंसर V. The potential will be equal to C1V1 plus C2V2 plus C3V3 by C1 plus C2 plus C3. That's it guys. This is the correct answer. एकदम single step solution. Great solution for you guys here. तो अगर आपको ये solution अच्छा लग रहा है और ये symmetry जो भी concept अच्छा लग रहा है, I want all of you guys to share it, like the video right away and share it everywhere. ठीक है? So awesome tricks upcoming. Yes, so this is thank you. This is what I want you guys to have. I want you guys to have clarity. एक बात याद रख लेना, this is always any nodal analysis you have to understand that in this closed surface the total charge will always be 0, because there is no potential difference. All of them are equipotential surfaces and everything is equal potential. It means charge inside will be 0. Getting it? All right, very good guys. Now this is one of those questions which you already did this kind of question yesterday, but चलो फिर से देख लेते हैं. In the given figure, a capacitor of plate area A, this has an area A, is charged up to charge Q. It's given a charge Q. ठीक है, ये charge Q होगा तो ये minus Q हो जाएगा. The mass of each plate is M2. Mass of each plate is M2. The lower plate is rigidly fixed. Find the M1 so that the system remains in equilibrium. Find the value of M1 so that the system remains in equilibrium. This is the question, guys. तो इसका आंसर मैं आपको टाइम देता हूं। तो ये क्वेश्चन में you can use two different things. One is gravity, Newton's laws of motion का equation लिखना है एक प्लेट के लिए. You write the equation for the plate, then you can take it to be in equilibrium and find out net force on both sides. तो देखने में सिमेट्री से लगता है एक्चुअली आंसर, इसमें देखने में ही you can get out the answer. Alright, 1 minute हो गया, so let's start solving this question guys. तो इसमें क्या हो रहा है बेसिकली अब बताओ. अब ये प्लेट का देखेंगे बिकॉज दिस प्लेट इज हैंगिंग इन एयर, दिस इज हैंगिंग इन एयर, एवरीथिंग एल्स दिस इज ऑन ग्राउंड, सो इसमें कुछ भी फोर्स से हमें फर्क नहीं पड़ेगा. मास ऑफ ईच प्लेट. तो लेट्स ड्रॉ द फ्री बॉडी फॉर अपर प्लेट. इसका अपर प्लेट का फ्री बॉडी डायग्राम खींचेंगे. ऑलराइट, तो यहाँ पे एग्जैक्टली आई थिंक ए इज द राइट आंसर. भाई देखते ही समझ में आ जाएगा. देयर इज वन प्लेट हियर which is having one tension in the upward direction. एक तो M2G ग्राउंड के डायरेक्शन में है, और the plates will attract each other which a force which is equal to field into charge. ठीक है, तो इससे हम, और इस अपर ब्लॉक का अगर देखा जाएगा M1 ब्लॉक का, ऊपर टेंशन है, नीचे M1 है. तो these are the two free body diagrams we need to draw. इसका फर्स्ट इक्वेशन हम लिख देंगे. The first equation we'll get from this block will be M1G minus tension is equal to 0, which means tension will be equal to M1G. हो गया एक. This is the first thing we got. And using this free body diagram, we will write equations now. Equations using this. Tension will be equal to M2G plus field into Q. अभी फील्ड कितना है, इलेक्ट्रिक फील्ड जो इनसाइड इनसाइड inside a capacitor is equal to Q by epsilon naught A, right? Field इतना ही है due to capacitance, so let's substitute there. So tension will be equal to M2G plus Q square by epsilon naught A. टेंशन कितना हो, M1G हुआ, सब्स्टिट्यूट कर लो. M1G is equal to M2G plus Q square by epsilon naught A. इससे आ जाएगा आंसर M1 is equal to M2 plus Q square by epsilon naught Ag, which is the answer, right? So grade 1 guys, simple, good one, sim 24, very great answer. So this is how we got it. हो गया simple. ये क्वेश्चन, हाँ ये क्वेश्चन करते हैं. If an electron enters a space between the plates of a parallel plate capacitor at an angle theta 1 and the plates leaves at an angle theta 2 to the plates, the ratio of kinetic energy while entering to that while leaving is. This is a very logical question. ठीक है, ये बहुत लॉजिकल क्वेश्चन है क्योंकि इसमें हम एक बस मस्त फंडा, इट एंटर्स द रीजन एंड लीव्स द रीजन. तो इसमें पहले डायग्राम खींच लेते हैं कैसा होगा. ये पैरेलल प्लेट कैपेसिटेंस है, ठीक है. इलेक्ट्रॉन ऐसा आया है एक एंगल थीटा 1 से, थीटा 1 से आया ऐसे, और ऐसे चलते चलते टाइम ऐसे करके थीटा 2 हो गया उसका एंगल. दिस इज द इलेक्ट्रॉन विच इज नेगेटिवली चार्ज, हेंस द रेड कलर. ये आया है यहाँ से और वहां चला गया थीटा 2 से. तो द सॉल्यूशन फॉर द स्पीड रेशियो ऑफ काइनेटिक एनर्जीज, इट स्टार्ट्स नाउ. 1 मिनट दे आपको. तो इसका आंसर 1 मिनट देता हूं फिर से, बहुत इजी क्वेश्चन है। कम ऑन गाइस, दिस इज एन इजी क्वेश्चन। मतलब इसमें एक बात याद रखना है, पैरेलल प्लेट कैपेसिटर्स पे द फील्ड विल बी फ्रॉम वन प्लेट टू द अदर प्लेट। टाइम हो गया है, अभी तक आंसर तो नहीं आया, तो लेट्स सॉल्व इट। ठीक है, वन थिंग वी नो हियर, यहाँ पे प्लस क्यू ले लो, यहाँ पे माइनस क्यू ले लो, यहाँ पे प्लस क्यू ले लो, बिकॉज इलेक्ट्रॉन है ना। हाँ ठीक है, यहाँ प्लस क्यू ले लो, यहाँ पे माइनस क्यू ले लो चार्ज। तो यहाँ एग्जैक्टली गुड वन सिम 24, दिस इज द राइट आंसर, ए इज द करेक्ट आंसर। तो इसमें फील्ड is in this direction. All right, so force acting on the electron will also be in this direction. Force on electron will only be in the perpendicular direction. तो इसमें क्या समझना है हमें, the force on the electron is only in the perpendicular direction, in the y axis basically, ऐसे सोच लो। तो इससे क्या आ जाएगा हमें, the force in the x direction will be constant 0, which implies velocity in the x direction will remain constant. स्पीड बदलेगा बट वेलोसिटी इन द एक्स डायरेक्शन कांस्टेंट रहेगा। तो इनिशियल स्पीड u ले लो, फाइनल स्पीड v ले लो। तो व्हाट कैन यू से, द कंपोनेंट अलोंग द x डायरेक्शन vx will be same, which implies u into cos theta 1 will be equal to v into cos theta 2, वही है। अब v by u हो गया आंसर इसका, cos theta 1 by cos theta 2। तो काइनेटिक एनर्जी रेशियो कितना होगा, रेशियो विल बी हाफ m v1 फाइनल स्क्वायर माइनस, while entering to that of leaving मतलब इसका रिवर्स ले लो, u by v कितना हो गया, cos theta 2 by cos theta 1। तो रेशियो ऑफ काइनेटिक एनर्जीज हो गया हाफ m u स्क्वायर बाई हाफ m v स्क्वायर, which is nothing but u square by v square, which is cos theta 2 square by cos theta 1 square। तो देयर यू गो गाइस, एकदम मस्त आंसर आ गया फिर से, वेरी गुड सिम 24, ग्रेट जॉब। सो these are a few problems which I wanted to explain। मतलब ये कैपेसिटेंस के अंदर जो होते हैं, the applications of capacitances, I wanted to give you a little idea about how to apply capacitances in mechanics and different kinds of other problems। All right, so before we go further, crack IIT-JEE with India's largest platform, which is Unacademy. Get the plus subscription to access unlimited live recorded sessions from across India's best educators से मिल जाएगा, ठीक है। So what do you get with plus subscription? You get access to best of Unacademy, which is daily live classes where you can chat with your educators and you can engage in live discussions। कुछ भी डाउट है वहां पे पूछ सकते हो, और आंसर पूल्स ऑल व्हाइल क्लास इज गोइंग ऑन, एवरीथिंग यस व्हाइल द क्लास इज गोइंग ऑन। मस्त होता है इंटरेक्शन। यू कैन ऑल्सो चेक माई डेली क्विज शो which I have actually been conducting for the last 10 days, for the last 2 weeks। Daily quiz show एक show है, every day we have a quiz show, lots of people coming in, we have loads of fun there at 10 o'clock every day, ठीक है, 10:30 p.m। All right, not only this, we get live tests and quizzes, daily quiz show की तरह you will get live tests and you can evaluate your with your preparation with regular mock tests। मतलब हर टाइम एक mock test लिख सकते हो, like a quiz a day keeps you ready for JEE any day, so you need to quizzes and tests, and that you will get at Unacademy in the app with the plus subscription। All right, not only that, you have a lot of structured courses there, the entire course will be given to you structured chapter by chapter by chapter and point by point, and you will have it at your phone or at your one click every time। मतलब तू जब चाहे तब पढ़ सकते हो। It's not like in the outside classes when you miss out on a class, it gets tough to come back, right, because the teacher is already going in a flow। but यहाँ पे you will have a flow जो तू जब चाहे you can you can take the course, and you'll have unlimited access to all the teachers from across the country। All right, so this is it। So the cost of plus subscription is 38,500 for 1 year, it is 28,000 for 6 months। for those who want to crack 2021 JEE, this is the code you can use, Hello, Giri Babu. So not only this, use this code NSS1. Use this code NSS1 and you get it extra 10% off, which will make it 34,650. अब इसका कॉस्ट ज्यादा लग सकता है, but let me tell you, it costs 32 rupees per day per subject. 32 rupees per day. अगर तुम if you are preparing every day for IIT-JEE, then this is a very good offer. Like Joker says, when you're good at something, never do it for free. That is what that is what Unacademy is charging you this normal fee. You can also get no cost EMIs. और ऐसे कि those who are cracking 2022, you can take this 2-year course which is costing 56k. It is much than this, by the way, double से कम है. और ये code use करो 50,400. NSS1 is the code, and this 23 rupees per day. Those carry, you will get it for 23 rupees per day per subject. So this is the beauty of it. Not only this, Unacademy has also launched. Not only this, Unacademy has also launched an iconic subscription where you get an extra personal coach. This is for those guys who need help from teachers. This is for those guys who need help from teachers. The teachers are here. They are experts. Expert guidance. You will get expert guidance from top coaches who will align your preparation strategy. Matlab, these guys they will help you with your preparation strategy, where detailed test analysis is given to you, and along with this, based on your test analysis, you will be given a study planner, and it will be monitored by your personal coach who will guide you through the entire course. All right. Not only this, you also get all the benefits of Plus. Everything in the Plus personal coach. The cost of this is 56,000 for 1 year. जैसे कि कोड यूज करेंगे तो NSS1 you get it for 50,400, which comes out to 46 rupees per day per subject. Pretty cool. 2 years का 2022. This is 86,000 for 2 years, which comes out to use the code NSS1, you will get it for 77k. This will come out to again 32 rupees per day. मतलब आप बताओ 32 rupees per day में तुझे एक टीचर भी मिल रहा है वहाँ पे. If you're cracking the best thing, especially in this time of corona where you don't know how many waves are going to come. मतलब अभी पता भी नहीं है. ठीक है, तो stay at home. Again I'm telling you, stay at home, stay safe, don't go outside. Crack IIT-JEE with Unacademy. All right, so now we are going to discuss about the next topic, which is dielectric. चलो हम एक बार डाइलेक्ट्रिक के बारे में थोड़ा देखते हैं बिफोर वी गो फर्दर. So what happens when you place a dielectric? What is a dielectric? Now dielectric, एक जैसे कि यहाँ पे लिखा हुआ है, it is an insulator in an electric field. Basically what happens when conductors are placed in electric field, they get polarized completely. पॉजिटिव चार्ज एक एंड पे चला जाएगा, नेगेटिव चार्ज एक एंड पे चला जाएगा, और पूरा देयर वोंट बी एनी फील्ड इनसाइड द मेटल. बट व्हाट अबाउट इंसुलेटर्स? इंसुलेटर्स ना पूरा आधा करेंगे. दे वोंट, इट्स नॉट लाइक इंसुलेटर्स आर अफेक्टेड बाय फील्ड. They also have effect on them, but it will be on a little. So from this directly, polarized dielectric has surface charge density of, so normal metal जो है, for metal the surface charge density will be equal to the surface charge density of the capacitor plates. ठीक है, पर ये insulator में थोड़ा ratio है. The insulator में not entirely it will become like a field, so there will be part of it which will, there is a part of it which will get induced and part of it which will not get affected by the capacitance. ठीक है, तो यहाँ पे इसके बारे में हम पढ़ेंगे आज. तो जैसे कि यहाँ देखिए, यह नेगेटिव है तो यहाँ पे थोड़ा पॉजिटिव आ जाएगा. दैट विल बी सम लिटिल डेल्टा ई टाइम्स डेल्टा क्यू, और यहाँ पे थोड़े डेल्टा क्यू चार्ज नेगेटिव इस साइड आ जाएगा, जबकि यहाँ पे क्या चार्ज क्यू एंड क्यू है. दिस डेल्टा इज द रेशियो, दिस इज ओनली द परसेंटेज ऑफ इंड्यूस्ड चार्ज. So this induced charge ratio will only affect the dielectric. Understood? इसका रिलेशन होगा डेल्टा K will be equal to 1 by 1 minus delta basically. तो ये है इन दोनों का रिलेशन. ये कैसे आएगा ये सब हम अभी देखेंगे. This is just a very simple way of understanding it. The ratio of induced charge is nothing but dielectric constant का रिलेशन ये है. ठीक है, इसके बारे में थोड़ा पढ़ेंगे, then you will understand more and more about this. One thing we know for sure that the induced charge cannot be greater than the charge itself. उसके हिसाब से ये हो जाएगा. ठीक है, तो ऐसे कि जैसे हम यहाँ पे फील्ड के अंदर अगर if you have a dielectric here, so now how is the, what is happening here? Now I want you guys to understand the other side of it. What is happening here? यहाँ पे बाहर फील्ड है, ठीक है, और यहाँ पे electrons, the charges are, ions are getting exactly adjusted based on the field. तो negative charge इस side रहेगा, positive side रहेगा. As a result of its inside, there will be another extra induced field. Inside there will be extra induced field to an insulator being present. अगर वो metal conductor होता तो पूरा उल्टा कर देता. So net force. So from this also we can say that E net the E net will be equal to E naught plus E inside. तो इस साइड इस तरीके का हम पहले ऑलरेडी डिस्कस कर चुके हैं. Looks like same, exactly, it looks like that only. F by 2 is equal to 1 by gamma minus 1. So this is to that. Good observation, man. Sim 24. This is what I like. We have to be able to link everything. Once you know one formula, you can use every other thing in the same ratio. तो ये जो है इस हम सॉल्व करना शुरू करेंगे. All right. So now let's talk about filling a capacitor with a dielectric increases the capacitance by factor equal to the dielectric. ये कैसे होगा हम एनालाइज करेंगे इसको. Let's start analyzing. All right. तो यहाँ पे देखो, यहाँ पे there is charge plus q here and charge minus q here, the separation of d, and we all know that v is equal to ed. So v will be equal to v by d. तो ये सब ऑलरेडी पहले से है. The electric field in this case will be v by d. All right. तो अगर हम यहाँ पे एक डाइलेक्ट्रिक इंट्रोड्यूस करेंगे, when we introduce a dielectric to this, when same thing, the same thing, अब we are introducing a dielectric here. ठीक है, we are introducing another dielectric in between. अब इसको यहाँ इंट्रोड्यूस करने से क्या हो जाता है, that is what we want to discuss. So one thing we know when dielectric is introduced, one thing we know, the field here becomes how much? Field after introducing dielectric will become E naught by K, right? One thing we know पहले से कि the field initially अगर field E है in vacuum, once you introduce a dielectric constant K, the field later on will become E naught by K. ठीक है, ये बात तो क्लियर है. तो then what will potential become? Potential is nothing but ED, right? तो potential भी V naught by K हो जाएगा. तो इससे क्या समझ में आएगा? When you put a dielectric, when dielectric is put, what will happen? The difference will become by K. The potential difference final will be V naught by K. तो इससे क्या इफेक्ट आएगा? Capacitance will be Q by V naught by K, which is nothing but Q by V naught into K. ये initial capacitance है. तो C final will become K times C naught. So this is the concept, guys. इससे हमें बहुत simple understanding हो गया based on charge. So इससे हमें क्या समझ में आया? That the capacitance will increase. Initial capacitance C naught है. ठीक है, Q naught Q by V was equal to Q naught by V was equal to C naught. तो यहाँ पे Q naught by delta V C naught by K जो हो गया, ये multiplication factor आ गया. तो इसके कारण this whole thing is C naught. You will get the value to be K times. So based on the more higher dielectric, more the so the capacitance of a surface is also proportional to the dielectric. This is one more thing I want you guys to write it down. ये सब लोग लिख दो और share कर दो everywhere. All right. So now next thing, a parallel plate capacitor with area A and distance D is between the plates and is connected to a battery. What happens to the capacitor's charge if the glass plate is then inserted between the plates? So this. So what is? All right. So, okay, I think it is clear only. Is it fine now? A parallel plate capacitor with an area A and distance D between its plates is connected to a battery. Okay, initially there is some charge there. What happens to the capacitor's charge Q if the glass plate is inserted between them? इसका आंसर सोच लो आप, इट्स अ वेरी थियरिटिकल क्वेश्चन, सो इसमें जस्ट ज़्यादा सोचने का नहीं है. तो विल सी, आई एम गिविंग यू 30 सेकंड. एक बहुत सिंपल लॉजिक है इसमें. व्हाट विल हैपन इफ वी, तो देखो, as one thing we know about capacitance, यहाँ पे when a glass plate is introduced, what happens? It is a dielectric. Glass plate is a dielectric. तो उसमें क्या होता है, उसके कारण the capacitance of the plate will increase. Yes, good one. It is answer B. Very good, great job. ये वही है, simple concept है इसमें. All right. So what happens here is, once a glass plate is introduced, glass is a dielectric. Glass is dielectric. तो उसके कारण capacitance क्या हो जाएगा? Capacitance will become K times C naught. And what do we know about charge? Charge is nothing but C into V. तो initial Q naught हो गया C into V. Q final कितना हुआ? K times CV. क्योंकि capacitance final बदल बदल गया. तो इससे what can we get? That the charge increases and it increases K times the dielectric times. Understood? So this is a great solution. Good one. Good one, yaar. Giribabu and Sim24. Great going. Now for the next one. So this is what happens in a parallel plate capacitor. ये हम already discuss कर चुके हैं. So it's a more visually strong so that you can understand and remember these things. Okay. One thing we know. So what happens when this dielectric is introduced? So one thing we know, the field becomes K times, which is what we discussed. Initially field kitna tha, sigma by epsilon, which is equal to E by D. But once you put this, the polarization, which is exactly what we discussed, the polarization of the dielectric will reduce the field effect to E naught by K. Getting it? ये polarized charges के कारण the field will become E naught by K, as a result of which the E effective will be now, so the field effective will now become 1 by K times. Clear, guys? If this is clear, I want all of you guys to, yes, Anjali, yes. Is it clear? Due to this extra polarizing effect, it's all vectors. No, the moment you see field is a vector, you can just add all vectors. तो इसमें क्या है? इसमें यहाँ पे field एक है, और because of this polarizing, there will be an extra field E polarized in the upward direction. Hence, दोनों को मिला के we will get the total capacitance to be K epsilon naught A by D, and hence we will get the capacitance is K times C naught. All right, so great one. So now next thing we have to understand the charge flowing from a battery. We will just analyze what happens inside a battery now. अगर ये setup एक battery को connected है ऐसे, what is the charge flowing through the battery? As we see here, it's a metal plate. Metal plates can also be forming two parallel metal plates form a parallel plate capacitor. एकदम सबको पता है ना? यहाँ पे क्या? What is the flow of charge? So first thing we know, initially Q naught, Q on each plate. So let's उसको diagram में draw कर देते हैं. So Q on each plate initial will be equal to Q naught and minus Q naught, and Q naught was equal to C into V, right? इसका capacitance V मान लो, यहाँ पे C मान लो, इसका capacitance, sorry, इसका capacitance C ले लो, इसका potential difference V ले लो. So this is what it will look initially. So once you put a dielectric in it, अब ये क्या हो जाता है? Once I am putting a dielectric here, तो अब क्या हो जाएगा? This plate का capacitance will become K C naught and this V is C, so Q final will be equal to K C naught V, or it is also equal to K C V. So what is the total charge flow? Charge flow is nothing but final charge minus initial charge. इतना electrons है, ज़्यादा जा रहे हैं ना इसमें, more electrons are going out now because of dielectric. So Q final minus Q initial हो जाएगी, which is nothing but K minus 1 into C. Charge flow will be equal to K minus 1 into CV. It's very simple, guys. Charge will be K minus 1 into CV. Understood? Clear है ना सब कुछ एकदम? Very nice. Now, one more thing we'll discuss about energy. What is the energy dissipated from the battery? ये कैसे होगा? मतलब battery is maintaining a potential difference. What does battery do? It will maintain this potential difference V. And इतना charge इससे यहाँ तक चला गया. So what is the work done? It is nothing but VQ. हो गई ना बात? V into Q कितना है? Q flow. Q flow कितना है? K minus 1 into CV. तो इससे आ जाएगा K minus 1 into CV square is the heat, is the energy spent. Energy spent by battery. क्लियर? सो दिस इज अ वेरी नाइस, मतलब सब एकदम एक आएगा तो सब कुछ एकदम ऐसे ही फ्लो में आते रहेंगे. सो वंस यू नो वन, यू विल गेट एवरीथिंग इन द सेम वे. Clear? So this is it, guys. So this is about how battery gets impacted by charge flowing through the capacitor, and we already discussed what happens to the capacitor. The capacitance becomes k times. Clear? All right. Now when multiple, so today now next we will discuss about when multiple dielectrics are placed in a slab. All right. We'll discuss when multiple. When should we take V is equal to V naught by K? So we will discuss that also in the slides as we go. All right, we will discuss all of them. We will discuss this in today's class on Sim 24. Just stay tuned and share this everywhere. Okay, stay tuned. हाँ, तो each slab, if you observe the whole thing, ये एकदम पूरा लिखा हुआ है clearly. मैंने लिख दिया पहले से ही. Multiple dielectric slabs are placed in a capacitor. नॉट जस्ट वन बट मल्टीपल. यहाँ पे एक ऐसा है K1 लिया, यहाँ पे K2 है, यहाँ पे K3 है, and all of them have separate thicknesses T1, T2 and T3. So now you can imagine each one to be like a capacitor, right? If you observe carefully, you can take each one of them to be a capacitor. कि यहाँ से यहाँ तक एक capacitor है, like we discussed, any conductor plate will become a capacitor. Same way, any semi-conducting plate also will become a capacitor, provided you can just imagine a vertical plate there. So this will become one capacitor C1, ये बन जाएगा C2 और ये बन जाएगा C3. So what is capacitance here? Everywhere it will be each one will have capacitance of epsilon naught into A into epsilon naught A by thickness into dielectric constant. So epsilon naught A तो यहाँ सबका common है because everything has same area. Every dielectric has same area and it also has same charge. ठीक है, तो यहाँ पे जो चार्ज है वहाँ पे भी सेम चार्ज है इवेंचुअली, which means the total charge inside will also be zero, which means every plate will have same charge. So using these both logic, we can say these both, all the three of them are in series. All the three dielectrics are in series. तो एक एक का individual dielectric अगर कैच करेंगे each का capacitance, तो each one will have epsilon naught into area A by T1 into K1. हो गई बात. Everything has the same thing, epsilon naught K1 by T1. C2 will have epsilon naught K2 by T2, and C3 will have epsilon naught into area of surface which is A into T3 K3 by T3. So इसके बाद since they are all in parallel, we will get C equivalent will be equal to 1 by C equivalent will be equal to 1 by C1 plus 1 by C2 plus 1 by C3. This is coming out to be this one, guys. तो ये है टोटल कैपेसिटेंस. क्लियर? तो इसमें एक स्मॉल क्वेश्चन, लेट्स हैव अ स्मॉल क्वेश्चन हियर. इट्स वेरी सिंपल क्वेश्चन. टू डायलेक्ट्रिक्स ऑफ कैपेसिटेंस आर शोन, capacitors are shown in the figure. The capacitance in the absence of dielectric is 10 microcoulomb. The capacitance of the given orientation is, assuming it is equally spaced. ठीक है, तो इसको यहाँ रख दूंगा. So the time starts now. Let's see who gets the answer right. Come on, guys. Come on, Ashish. When will B be V naught by K? We will discuss this as soon as these both are done. We will have that only. That is also there in the topic of discussion. Right? Okay, 1 minute हो गया and we have not got a response. So fine, I'm going to solve it for you guys. तो देखो इसमें सिंपल है, we can directly use of the formula we derived or we can also break it into two parts. All right, so we will take two capacitances. ओके इसको ऐसे ड्रॉ करके देखेंगे तो ये एक कैपेसिटेंस हो गया, ये एक कैपेसिटेंस हो गया, दोनों का थिकनेस T/2 है। तो मान लो इनिशियल कैपेसिटेंस C है, इसका कैपेसिटेंस कितना होगा, C1 विल बी इक्वल टू एप्सिलॉन नॉट A बाई ये D/2 ले लो, तो D 2 टाइम्स K1 और C2 विल बी एप्सिलॉन नॉट A बाई D इंटू 2 टाइम्स K2। तो इससे C1 C2 आ जाएंगे। No, yes, C is the correct answer. Good one, Sim24. थोड़ा time हुआ, but you got it right. So C1 will be how much now? It is 2K times epsilon naught A by D. This is equal to 10 now, so you'll get 20 K1, which is equal to 40 microcoulombs, and C2 will be equal to 20 times K2, which is 60 microcoulombs. अब दोनों का कैपेसिटेंस इतना बढ़ गया। Yes, good one, Anjali. So total C effective will be 1/40 plus 1/60, which is equal to, from this we get C equivalent is equal to 120/5, which is 24 microcoulombs. Got it? So great one. This is the answer. Yes. So next, the same concept एक बार दूसरी तरीके से देखेंगे. Let's see it in a different angle. The different angle is when they are in series like this. Like parallel like this. मतलब यहाँ पे एक प्लेट है, प्लेट के अगेंस्ट नहीं, it's all across the plate. मतलब एक ही प्लेट को तीन डाइलेक्ट्रिक टच करते हुए जा रहे हैं। तो इफ यू लुक एट इट दिस वे, फ्रॉम हियर टू हियर दिस विल फील लाइक वन डाइलेक्ट्रिक, फ्रॉम हियर टू हियर यू कैन फील लाइक अनदर डाइलेक्ट्रिक, एंड फ्रॉम हियर टू हियर यू कैन फील लाइक द थर्ड कैपेसिटेंस। देयर आर थ्री कैपेसिटेंसेस, एक का K1 ले लिया, एक का K1 K2 K3 डाइलेक्ट्रिक है। तो आई एम टेकिंग दिस टू बी C1 C2 एंड C3। ओके, तो अब इन तीनों का कैपेसिटेंस लेट्स कैलकुलेट। वी नो C effective will be equal to C1 plus C2 plus C3 since they are all parallel. And one more thing we know, potential difference between them is same. Potential is same for everyone. So C effective will be C1 plus C2 plus C3. अब C1 कितना हुआ, एप्सिलॉन नॉट इंटू A, ये तीनों को A/3 टाइप ले लिए मान लो। Let's take three of them have thickness T1, T2 and T3. Okay, yes, let's take this this length is L, so we'll call this T1, T2 and T3. All right, and the separation between them is D. This is already there. तो इससे क्या होगा, epsilon naught into area of this will be length into T1. The thickness is T1 and the width is T1 and breadth is B. Breadth is B and thickness is T1, so we'll get B T1 by D into K1, and C2 will be epsilon naught into B into T2 by D times K2, and C3 will be epsilon naught B into T3 by D into K3. सबके यहाँ पे thickness T1 T2 T3 है और width B है. The width of this is B. The total length we can also see T1 plus T2 plus T3 will be equal to L. This is one more equation we can also take. वो जो हम जब चाहे तब यूज करेंगे, we will use it when we want. But otherwise we got into each individual capacitance. It is epsilon naught into area by D into dielectric constant. So epsilon into BT1 by D into K1, BT2 by D into K2 and BT3 by D into K3. So C effective will now be epsilon naught B by D into K1 T1 plus K2 T2 plus K3 T3. That's it. तो ये हो गया इफेक्टिव कैपेसिटेंस। इसमें हमें थिकनेस से मल्टीप्लाई करना है। वी हैव टू मल्टीप्लाई थिकनेस एंड द डाइलेक्ट्रिक कांस्टेंट, and one more equation we have T1 plus T2 plus T3 is equal to L. So this is the next important point. So anything you want to write, just pause this video here and start writing. All right, इसको pause करके तुरंत लिखना शुरू करो। Okay guys, so we have three capacitors in parallel when they are dielectrics perpendicular to the plates of the capacitors. All right, so this is one example here. So the question is, find the two dielectrics are shown in the capacitors as shown the figure here. They are equally distributed, like half. So what is the capacitance in this given orientation? The answer is the options are right in front of you, and you can answer it now. Yes, very good, Anjali. Great job. Fatafat. Within 25 seconds, you got the answer. Good one. It's very simple. That's it. तो इसमें थिकनेस से हमें k से मल्टीप्लाई करने से हो जाएगा T2 K2. What did we get? Epsilon naught into B. So इसका पहले मान लो, इसका एरिया A मान लिया, ठीक है. So this question, let's take this area total to be A. तो इसका A by 2 हो गया, इसका A by 2 हो गया ना. तो C1 will be epsilon naught into A by 2 by D into 2. और C2 कितना हो? एप्सिलॉन इंटू A by 2 by 3, 3 into 3, इसका डायरेक्टिव 3 है. C total will be equal to epsilon naught A by D plus epsilon naught A by D into 3 by 2. हो गए ना? 5 by 2 times C, which is 25 micro. So yes, good one guys, great one. Now for the next question, partial filling of dielectric. तो पार्शियली अगर डायरेक्टर को फिल करने से क्या होता है? वन थिंग आई वांट यू गाइस टू नोट पहले कि यहाँ पे जो फील्ड है, सो बेसिकली व्हाट आई वांट यू गाइस टू अंडरस्टैंड इज द पोटेंशियल डिफरेंस विल बी इक्वल टू E into T, राइट? E into thickness, E into separation. ठीक है. इससे एक मैं वेरी नाइस कॉन्सेप्ट आई टेल यू. So let's call here the field to be, so here the field we'll call it to be E naught by K, right? और यहाँ पे फील्ड E naught हो जाएगा, ठीक है. यहाँ पे जो भी E naught है इसका बाई K हो जाएगा इसमें. तो द पोटेंशियल डिफरेंस विल बी हाउ मच? एप्सिलॉन नॉट by K into T प्लस एप्सिलॉन नॉट E naught into D minus T. तो इससे हमें क्या पता चलेगा? इज दिस पोटेंशियल डिफरेंस डिपेंडिंग ऑन वेयर द प्लेट इज प्लेस्ड? इट डज नॉट डिपेंड ऑन वेयर द कैपेसिटेंस इज प्लेस्ड or the dielectric is placed. So from this directly you can say the capacitance is independent of the position of dielectric, because potential is also independent. Same way even capacitance will be independent of the presence of any dielectric. इसमें सिंपल हम जो प्रीवियस फॉर्मूला है उस टाइप का फॉर्मूला हम एक दिला, we can derive one formula like that. So this has an area A, ठीक है. तो capacitance 1, we know this is in parallel, we know these are in series. तो ये इसको C1 मान लेते हैं, जो एयर है उसको C2 मान लेते हैं, ठीक है. तो C इफेक्टिव कितना होगा? विल बी C1 C2 by C1 plus C2. और अब हम C1 C2 का वैल्यूज कैलकुलेट करेंगे, ठीक है. तो C1 का वैल्यू इन दिस विल बी इक्वल टू एप्सिलॉन नॉट इनटू A एप्सिलॉन नॉट A by थिकनेस हो गया इनटू K, एंड C2 हो गया एप्सिलॉन नॉट A by D minus T. तो अब टोटल 1 by C1 plus 1 by C2 अगर करेंगे तो 1 by एप्सिलॉन नॉट A कॉमन ले लो. इस फॉर्मूला को नहीं यूज करेंगे, we'll use 1 by C effective. It's all same basically. 1 by C is equal to 1 by C1 plus 1. So 1 by epsilon naught A I will take common, I will get T by K plus D minus T. तो इससे कैपेसिटेंस क्या हो गया? 1 by C will be equal to 1 by epsilon naught A into K. A कॉमन ले लिया तो T plus D minus T into K. तो इससे कैपेसिटेंस हो गया एप्सिलॉन नॉट ए के बाई डी के प्लस टी माइनस डी के प्लस 1 माइनस के इंटू टी. हो गई ये आंसर. अंडरस्टूड? सो दिस वे वी कैन जस्ट स्टार्ट सॉल्विंग बेस्ड ऑन सिंपल इक्वेशन कि क्या कैपेसिटेंसेस है इंडिविजुअली, उसके हिसाब से ये हो जाए. So one very important concept you have to understand here is it doesn't matter where the dielectric is placed. It only matters how the dielectric is placed. All right. So it is about how the dielectric is placed more than where it is placed. So that is it. जो भी doubt है इसको pause करके लिखते जाना everyone. All right. So now let's do a small example of this. Example. So the normal capacitance is 10 microcoulomb. All right. So now what is the capacitance if half of it is filled with dielectric of constant 4? इसका 1 ही है. अब C effective कितना होगा? तो इसको हम सॉल्व करेंगे. इट इज वेरी सिंपल यार. इसमें बेसिकली एक जैसे कि डाइलेक्ट्रिक फॉर्मूला है वही को यूज करेंगे. विल यूज सेम डाइलेक्ट्रिक फॉर्मूला but this time we'll just take k is equal to 1 in one particular case. ठीक है, we'll take k is equal to 1 in one particular case and we'll take k is equal to 4 in the other particular case. That's it. तो यहाँ पे t by 2 है, यहाँ पे t by 2 है, तो c1 will be equal to epsilon naught into a by t 2 times and 4 और c2 हो गया epsilon naught a by t into 2. t by 2 है तो ऊपर कर दिया इसको. तो इससे टोटल c इफेक्टिव कितना आएगा? इसका 8 एप्सिलॉन नॉट a by d t हो गया और इसका 2 एप्सिलॉन नॉट a by t हो गया. तो ये 2c है और ये 8c है. Combination of both of them very good one. The combination of both of them will be c1 c2 by c1 plus c2. C effective will be C effective will be equal to c1 c2 by c1 plus c2. ये भी फॉर्मूला यूज कर लेंगे which is 8c into 2c by 10c which is 1.6c which is 16 microcoulomb. Very good one, Divya. Great job, Divya and Anjali. Yes. Now bound charges on a dielectric surface and a charge. We already discussed about this कि हम एक logic we will derive this once you get into the class, right? So this is what I want to derive it for you guys. यहाँ पे मान लो एक फील्ड E है, ठीक है. You know one thing that here the field will be backward direction. This is E polarized. I'll call this EP. तो field inside, तो इन दोनों को यूज करने से क्या बोल सकते हैं? Field inside will be equal to E minus E polarized. Getting it? So इसका the amount of charge density on the dielectric surface, इसका सिग्मा है तो सिग्मा इंड्यूस्ड यहाँ पे सिग्मा आई मान लेते हैं. तो इसको हम सीधा लिख सकते हैं सिग्मा इनसाइड इज गिवन बाय सिग्मा बाय के, राइट? You know field inside is equal to E total by K, right? We'll just substitute this, which implies field inside is general and field is given by sigma by epsilon naught. तो इसको यहाँ पे यूज कर लेते हैं. I will use sigma by K epsilon naught will be equal to sigma by epsilon naught minus field due to P. इसका हम अगर रेशियो मान लेते हैं तो इसको भी हम लिख सकते हैं सिग्मा इंड्यूस्ड बाय एप्सिलॉन नॉट. तो इससे सीधा सिग्मा इंड्यूस्ड आ जाएगा. सिग्मा इंड्यूस्ड बाय एप्सिलॉन नॉट इज इक्वल टू सिग्मा बाय एप्सिलॉन नॉट minus sigma by k epsilon naught, which is also equal to sigma by epsilon naught into 1 minus 1 by k. This is what we discussed previously, guys. This is the ratio of charges induced. The charge induced is equal to charge into 1 minus 1 by k. This is what we just figured out. ठीक है, मस्त है ना? तो इसका induced charge in terms of electric field अगर लिखोगे तो you can write it as epsilon naught into E. So 1 minus 1 by k. So this is what I was telling you guys. एकदम clear है ना सबको? मस्त. So the induced charges will be proportional to the field which is already present. The induced charge density will be proportional to the original charge density of the plates also by using this particular link. Note this down, guys. Note this down quickly. All right. Next, now this is what Sim24 has been asking. When the battery is connected, what happens when we insert a capacitor into when we insert a dielectric into a capacitor? So मान लो the system looks like this. There's a capacitor here connected across a potential difference. कुछ बेसिक थोड़ा बड़ा दिखना है इसलिए वो बड़ा कर दिया मैंने. ठीक है. इसमें हम now we are introducing a dielectric here. We are placing a dielectric. The first assumption we'll take is that dielectric will cover the entire thing. ठीक है. The dielectric will take the entire thing. आधा आधा है तो अभी तक देख लिए. We found out when half the dielectric is placed inside, when full dielectric is placed perpendicularly, parallelly, all these things. But now we'll discuss about what happens when generally a dielectric of constant K is put. In इसको और that को we can relate both of them together eventually. But for now, this is what happens. So one thing we know, when the battery is still connected, what happens? Will the potential difference change? No. When the battery is connected, the potential difference will remain same, but the capacitance will increase by K times. Clear? The capacitance increases by K times, but the total potential difference will remain same. Hence, we know charge is capacitance into voltage potential difference. So this will also increase by K times. And what will happen to the field inside? Batao. Field in general will become E naught by K, right? Or E naught is proportional to charge, right? So it is, what is field inside is generally given by sigma by epsilon naught into 1 by K. But we know sigma is becoming K times K sigma naught. तो इससे क्या आ जाएगा? Sigma naught by epsilon naught हो जाएगा. It's only initial. Clear? I hope this is clear to you guys. दो बढ़ेंगे. One thing, what is the field generally? Field is generally given by sigma by K epsilon naught. ठीक है. तो initially K1 है. So E naught will be equal to sigma naught by epsilon naught, and E final will be equal to sigma final by K epsilon naught. अब sigma final कितना है? It is based on, is proportional to charge, and we discussed charge is becoming K times, so sigma final will be K times sigma naught. तो हो गया sigma naught into K by K into epsilon naught, K gone, this is equal to E final. Understood guys? तो इफेक्टिव फील्ड तो सेम रहेगा, तभी तो पोटेंशियल डिफरेंस, ये सब की बात छोड़ दो, पोटेंशियल डिफरेंस इनटू डी इज ओनली नो. तो ये जब सेम है ये भी सेम रहेगा. क्लियर? सिंपल. एंड व्हाट अबाउट टू द पोटेंशियल एनर्जी स्टोर्ड? एनर्जी स्टोर्ड इज प्रोपोर्शनल टू के. इट इज बेसिकली डिफरेंट, इट इज गिवन बाय हाफ CV स्क्वायर ना. पोटेंशियल एनर्जी को हम अलग तरीके से लिख सकते हैं. पोटेंशियल एनर्जी इज हाफ CV स्क्वायर. तो मतलब इट इज प्रोपोर्शनल टू C. वोल्टेज फिक्स्ड है, कैपेसिटेंस पे प्रोपोर्शनल है, तो यू विल बिकम K टाइम्स. So understood? Yes, this is what I wanted. This is what Sim24 was asking. So when battery is connected, the potential difference will remain same. Now when the battery is disconnected after charging and the capacitor and the dielectric is inserted. Once the battery is disconnected and the capacitor is inserted, मतलब अब battery disconnect हो गया और यहाँ पे प्लस Q चार्ज और यहाँ पे माइनस Q चार्ज रह गए. The battery is now disconnected. Now what will happen? तो इसमें क्या होगा? One thing we know, there is no extra potential, no one is, the battery is not doing any effort, so the charge will remain same. ठीक है, यहाँ पे जो चार्ज पहले था that will remain same, and the capacitance will become K times C naught, which we already know. So what will happen to the potential final? It will be V naught by K, of course, because charge is product of these both. ये बढ़ गया तो ये घटना चाहिए. This should reduce because this is increasing. Q is equal to CV. So this is what happens to it, and by logic we know field is equal to V into D. तो जैसे कि पोटेंशियल घटता है, फील्ड विल आल्सो रिड्यूस. एंड व्हाट डू वी नो अबाउट पोटेंशियल इन टर्म्स ऑफ हाफ CV स्क्वायर लिख सकते हैं, और यू कैन आल्सो राइट इट एज Q स्क्वायर by 2C ना. हाफ CV स्क्वायर which is equal to Q square by 2C. So this is constant. This is becoming K times. So U final will be U naught by K. So that's it guys. This is the main difference between when dielectric is inserted before battery is closed or when battery is open. When battery is closed, battery will start giving additional charge, like we already solved the problem. But if battery is open, तब नया charge नहीं जाएगा. There is no new charge going anywhere. So what happens is the potential energy will reduce. Understood? I hope it's all clear. All right. The force on the next topic we'll discuss is very important, guys. So we can do one small problem on this. Is it clear? Okay. We'll do one small problem on this. one moment. A question right in front of you. Question says the ratio of energy stored after inserting dielectric K ratio of energy stored in a capacitor after introducing a dielectric 1 when switch is on, when battery is connected, 5 when battery is disconnected. Is 9. Alright. So the question says the value of dielectric constant is. Options are 9, B, 227. So yes, this is the question, guys. The ratio of energy stored in a capacitor after inserting a dielectric of K when battery is connected and second when battery is disconnected is 9. Yes, simple question. Good answer, both of you guys. Great job. The answer is B. So initial potential energy when battery is connected, potential energy कितना था? K U naught है. When battery is not connected, it was U naught by K. So you will just take both the ratios. You will get K U naught by U naught into K at top. You will get this K square is equal to 9. K value कितना होगा? Plus or minus 3. Electric का minus possible नहीं है, तो K will be equal to plus 3. Clear है ना सब? So this is great evaluation of it. I hope everyone understood this one. It's very simple. मतलब dielectric में ज़्यादा सोचना का नहीं है. Keep solving. All right. Now force on a dielectric slab during inserting a capacitor. The force on a dielectric slab during during inserting a capacitor. ठीक है. तो इसमें क्या हो रहा है? So this is a very trivial question. So before we go further, I will solve this. ठीक है. When a dielectric is inside up to a distance x, ये total length L है, इसमें x inserted है इसमें. The energy stored in the capacitor will be so. What will happen to it? When up to this much length x, the capacitor is there. So what we will do is, let's take area is A मान लो. So area of this area in dielectric will be, so हम एक करते हैं, ठीक है. So capacitance is given by epsilon naught A by D, right? So this total area of the plate is A. Area of plate is A. So now if you divide this is x ratio and this will be L minus x, right? If this is x, this will be L minus x. So the ratio of areas of both capacitors, ये मतलब it's a proper IQ based logic, ठीक है? So pay attention. Ratio of areas of both capacitors is proportional to x is to L minus x. So this is in the dielectric and this is not in the dielectric. So in this dielectric there is x length and outside the dielectric there is L minus x. So directly we can also write area of dielectric will be equal to epsilon naught A by D into x by L, and area which is outside will be equal to epsilon naught A into L minus x by D into L. एरियास आ गया, ठीक है. अब आप एक एक कैपेसिटेंस को कैलकुलेट करेंगे. P in the dielectric will be equal to epsilon naught A by D into x by L. ये सब नहीं है. एरिया ये है, ठीक है. तो epsilon naught A by D, तो इसका कितना है? epsilon by D into area. एरिया कितना है? AX by L आ गया सीधा. दिस इज करेक्ट ओनली into the capacitance K, ठीक है, which is nothing but kx times epsilon naught A by D into L. और कैपेसिटेंस वाला नॉर्मल वाला कितना हुआ? एप्सिलॉन नॉट बाई डी इंटू एल माइनस एक्स बाई एल इंटू ए. तो ये सीधा हो गया एल माइनस एक्स बाई एल इंटू एप्सिलॉन नॉट ए बाई डी. तो इन दोनों को अगर हम देखा जाए, सी के विल बी इक्वल टू के एक्स बाई एल टाइम्स सी एंड सी वन इज इक्वल टू एल माइनस एक्स बाई एल टाइम्स सी. C total अब हो गया K minus 1 into X K minus 1 into X plus 1 by L times K. Is it clear everyone guys? तो ये कैपेसिटेंस हो गया और ये पोटेंशियल डिफरेंस सेम है, ठीक है। तो वन थिंग आई वांट यू गाइस टू अंडरस्टैंड इज दैट द पोटेंशियल डिफरेंस इज सेम अक्रॉस बोथ ऑफ देम। यहां अगर देखा जाए तो लेट्स ड्रॉ द होल थिंग अगेन, वेरी स्ट्रेट फॉरवर्ड, मतलब इजी है। दिस पार्ट इज x and this part is L minus x, बस हो गई, ऐसे ही कर लो। Now what is the potential energy stored? If we calculate, we can calculate the force using that, ठीक है। तो potential energy is given by half CV square और C नॉट तो एप्सिलॉन नॉट A by D था और C फाइनल कितना आया, C of K will be C naught into K x by L and C of 1 will be C naught into L minus x by L. Right, L in AF. हाँ, गुड ऑब्जर्वेशन मैन, थैंक यू। तो ये दोनों हो गए, C K and this thing. So this one I'll also rate it as C naught minus x C naught by L. हो गए ना। तो I add both of them because they are in parallel, so I get a C effective. So इन दोनों का C effective कितना है, C naught into K minus 1 into x by L plus C naught हो गया। C final is equal to this much. So what is the change in potential energy now? Half into delta C into V square because we know V is fixed. और डेल्टा C कितना है, ये सीधा आ गया हाफ इंटू C naught into K minus 1 into x by L into V square is the change in potential energy. This is change in potential energy. And what do we know about force? Force will be equal to minus dou U by dou X. Based on this, we will get the value to be half C naught into K minus 1 into V square by L. तो ग्रेट सॉल्यूशन गाइस, दिस इज वी गेट इट। इसको पूरा डिफरेंशिएट कर दिए, इसको थोड़ा और नीटली लिख देते हैं, C naught into K minus 1 into V square into X by 12। इसको x से डिफरेंशिएट करेंगे तो ये x डिफरेंशिएट हो जाएगा एंड दिस विल बिकम दिस। क्लियर गाइस? तो दिस इज अबाउट द फोर्स। तो ये फोर्स अट्रैक्टिव है कि रिपल्सिव है? अब ये सोचो, पोटेंशियल एनर्जी बढ़ रहा है potential energy clearly is increasing, right? So if this is increasing, it means some external agent is doing work. Agent is doing work. Are you getting it? तो external agent work कर रहा है, मतलब potential energy is increasing, which means the force is opposite to it. The force, conservative force, the force from external is doing work, which implies force due to the dielectric will be negative, like it is repulsive. Getting it? तो इससे हमें क्या समझ में आएगा कि when you are trying to put a dielectric when the battery is connected, this is very important guys, this is the logic I want you guys to understand. When a dielectric is being introduced to a closed circuit, तो क्या होगा, then the force, the dielectric will experience a repulsive force. Dielectric will experience repulsion because क्यों, क्योंकि potential energy तो it wants to maintain minimum potential. हम we already know this, that the potential energy will be minimum at stable equilibrium, which means this is where the body wants to say, and यहाँ पे इससे ज्यादा ऊपर चला गया तो तुरंत force will be trying to bring it back to the original state. Getting it? So dielectric will experience a repulsion force. ऐसे सोचने से it will be much easier for you to analyze. Okay, इमेजिन पोटेंशियल एनर्जी बढ़ रहा है मतलब जस्ट एवरीथिंग, इमेजिन पोटेंशियल एनर्जी लाइक ए हिल. तो पोटेंशियल एनर्जी बढ़ रहा है मतलब यू आर गोइंग अप. How can someone go up when someone is doing external work? Only then he can go up. You cannot leave it to the conservative forces to just go up. When you leave it to conservative forces, which is gravity, you fall down the hill. Don't go up the hill. Same way, यहाँ पे भी potential energy बढ़ाना है मतलब the conservative force which is inside the electric forces due to dielectric will try to oppose that. Hence, you get a repulsive force there, guys. Is this clear? समझ में आ रहा है ना? So one more thing you have to understand: when potential energy is reducing, it means the force will attract. This happens when it is being introduced to a closed circuit. Closed circuit में अगर हम dielectric introduce करेंगे, then potential energy will decrease, which implies that the work done by conservative force is positive, work done by the electric force is positive, which implies the force is attractive. I hope this is clear, guys. If this is clear, I want you guys to share it everywhere. Just tell all your friends that I'm teaching some nice techniques here so that we can have more fun in the class. Alright. So this is about it. Acha, ab dekho. Let's solve a problem here. Capacitor of 5 microfarads is connected to 20 volt battery when a dielectric slab of K is equal to 3 is to the capacitor. The work done by the battery in supplying excess charge to the capacitor. This was supposed to be the previous question. It's a very easy question. Okay. तो इसमें क्या है? What is happening here? Simple. The change in potential energy is only work done by the battery. Battery is the external source here. Will be half into delta C into V square. अब डेल्टा सी कितना है? अब सीधा डायलेक्ट्रिक डाल दिए तो K minus 1 into C naught हो गया. बस single step answer. No need to do so many things like that, like this. C naught V square. Just substitute values here. Half into 2 into capacitance is 5 microfarad into V square, which is how much? 20 square. तो हो गई बात 5 into 10 to the power minus 6 into 400 into 10 to the power minus, what by the battery is delta CV square यार. सॉरी ये हाफ कहाँ से, हाफ नहीं गया, ये 10 है, 2 into 5 into this whole thing, so you'll get 10 into 10 power minus 6 into 400. So this is coming out to 4000 into 10 power minus 6 joules, which is 4 millijoules. Got it, guys? So it's a simple problem. You get the answer to be 4 millijoules because work done by battery is change in capacitance into V square. यही difference आपको जानने के लिए मैं किया हूँ. When dielectric is being introduced, with every change in X, the capacitance is increasing, right? But overall, the work done by the battery will always be change in capacitance into V square because change in charge, it only depends on change in charge. It is delta Q into V, which is nothing but C delta C into V into V, which is delta C V square. ठीक है, work done by battery ऐसा होता है, and when work done by external agent and all come into picture, that time you will get half the energy. Clear? All right. So now we will do some problems, little problems कर देते हैं इसमें, a little combination of capacitors. Now we know series, we know parallel. Let's do a simple question with the combination of both of them. All right. तो इसका आंसर मैं आपको दूंगा. I'll give 1 minute for you guys to crack this question. Easy है. This is also easy. It's about combination of series and parallel. We already discussed combination of series and parallel in yesterday's classes, and today we will be continuing that. So this is a great session. I'm bringing it to you guys. So please share this everywhere. Like, subscribe करो, bell icon दबाओ, do whatever is required and do the needed. Denominator is so let's see. ये थोड़ा मतलब it can feel a little lengthy, but I will explain it in one wonderful method. Okay. Abhi this question I will try to explain it in making it as simple as possible, especially when you have symmetric distribution like a by 2 here, a by 2 there, d here, d by 2 कर दिए सबको एकदम you just divided everything into one third one third one third type. This and very similar question came in IIT also. That is one more reason I gave this question, because recent IIT में एक very similar question came in. We will do that question after this. All right, guys, 1.5 minutes बच गए. Yes, A is not the right answer. A is not the right answer, man. All right, इसको हम solve करेंगे. चलो ठीक है. Let's solve this. Okay, let's solve this question. चलो कोई नहीं. तो इसमें let me tell you one thing. Capacitance is defined by epsilon naught into A by D ना. तो अगर एरिया हाफ हो गया और सेपरेशन भी हाफ हो गया तो कैपेसिटेंस सेम रहेगा इसका. ठीक है, अंडरस्टूड. The capacitance will remain same if area becomes half and this also becomes half. तो फर्स्ट वाला का कैपेसिटेंस कितना होगा? अब C1 will directly be equal to KC and C2 will directly be equal to K2C, which is equal to 2KC basically, right? और C3 में C is epsilon A by D, तो डिस्टेंस हाफ हो गया, एरिया सेम रहा, तो मतलब C3 ऑलरेडी विदाउट डाइलेक्ट्रिक विदाउट K3 is equal to 2 times C, और with dielectric you will get it to equal to K3 into C, K3 into 2C, which is equal to 6KC. Is this clear, guys? This is what I want you guys to understand. When capacitance have area halved and distance halved, तो capacitance same रहेगा. Other than that, there is also K multiplication factor. So C1 will become KC, C2 will become K2C, which is 2KC, and C3 में diameter भी half हो गया, K भी है. Diameter half होने से double effect आएगा और K का भी effect आएगा. So it is double combination with K3, which is equal to 6KC. अब देखो कैसे है सब. This is like this, and both of them are connected in series with this. So we get C1 parallel to C2 in series with C3. कैलकुलेट कर दो इसका वैल्यू KC plus 2KC in parallel with 6KC. So 3KC and 6KC are in parallel with each other. Oh, the answer is 2 only. Very very good. My bad. मुझे लगा आंसर 2 नहीं है. 2 ही है आंसर. 1 by 3KC plus 1 by 6KC is equal to 1 by C effective. इससे आ जाएगा 6KC by 3 is equal to 1 by KC effective. C is equal to 2K. Which is the right answer? Great one, Anjali. So very good going, guys. All right. So next, अगर इस क्वेश्चन में, this is a very theoretical question, इसके लिए हमें पहले we already discussed everything we need here. We already discussed everything we need here. So when a metal plate is introduced between the plates of a charged capacitor and insulated from them, the metal plate divides the capacitor into two capacitors connected in parallel to each other. Is that correct? Next, the metal plate divides the capacitor into two capacitors connected in series with each other. Is that correct? Or metal plate is equivalent to a dielectric of zero dielectric constant? हो सकता है. The capacitance of the capacitor decreases. Which of the following options are correct? तो इसको हम एक एक स्टेप एनालाइज करेंगे. Let's analyze it step by step. The metal divides the capacitor into two parallel capacitors connected in parallel with each other. इसमें क्या हो जाएगा? Let me speak. तो यहाँ पे we know what happens to a capacitor, right? When यहाँ पे प्लस चार्ज है, यहाँ पे माइनस क्यू हो जाएगा और यहाँ पे प्लस क्यू हो जाएगा. अच्छा, यहाँ पे माइनस माइनस हो जाएगा, यहाँ पे प्लस है, यहाँ पे प्लस है. When capacitance is introduced, यहाँ पे प्लस है, यहाँ माइनस हो जाएगा, यहाँ माइनस हो जाएगा और यहाँ प्लस. ठीक है. So based on whichever is more, whichever side the charge is more, यहाँ पे माइनस, यहाँ पे प्लस क्यू है, यहाँ पे माइनस क्यू है. This is minus q. So what happens is the charge here will be induced as minus q. यहाँ पे charge induced will be plus q. So the entire thing inside there will be field 0. The field inside will be 0. So the entire thing will behave like there is nothing happening there. So ultimately क्या होगा, ये जो thickness है और ये जो thickness है, ultimately these both only, D will ultimately become T1 plus T2. ठीक है, so distance between them is decreasing. Effective distance between the two capacitive plates where potential difference is occurring is decreasing, which means हमें in between का field तो same है because of charges and distance is reducing, which means the potential will reduce. ठीक है, and one more thing we know, it will become like this. यहाँ पे एक प्लेट को ऐसे मान लिए और यहाँ पे ऐसे, तो ये सब पूरा एक वायर हो गया, तो ये दोनों कैसे कनेक्टेड है? This is like a wire only, capacitor, wire is only conductor, wire is also a conductor, this slab is also a conductor. तो ये दोनों किस में है? सीरीज में है. So two capacitors are connected in series with each other. एक सही है. The metal is equivalent of a dielectric constant of zero dielectric constant. ठीक है, इसमें हम क्या फॉर्मूला डिराइव किए थे पहले? The induced electric field will be equal to sigma naught into 1 minus 1 by k. ठीक है, तो ये दोनों अगर इक्वल हो गए तो डाइलेक्ट्रिक कांस्टेंट कितना हो जाएगा? ये इंफिनिटी हो जाएगा ना. आर यू गेटिंग इट? वी विल गेट दिस एज इंफिनिटी, सो इट विल बिहेव लाइक अ डाइलेक्ट्रिक कांस्टेंट ऑफ इंफिनिटी, नॉट जीरो. तो ये क्वेश्चन गलत है. उसके बाद कैपेसिटेंस ऑफ द कैपेसिटर डिक्रीजेस. व्हाट हैपेंस टू द कैपेसिटेंस ऑफ द कैपेसिटर? इफ यू ऑब्जर्व, कैपेसिटेंस इज एप्सिलॉन नॉट A by D. नाउ D is decreasing, which means capacitance is increasing. हो गया. You can either see this or you can also say Q is equal to C into V. पोटेंशियल घट रहा है, ये सेम है, मतलब C को बढ़ना ही पड़ेगा. That's all. All right, understood? All right, now on to the next question. This is a multiple choice question, so this one I want you guys to answer carefully. तो इसको थोड़ा एनालाइज करेंगे and then we'll call it off. Okay, we'll do the other problems in the next class because we are already running out of time. तो देख, एक डाइलेक्ट्रिक स्लैब फिल्स द लोअर हाफ ऑफ द रीजन ऑफ पैरेलल प्लेट कैपेसिटर एज शोन. ये डाइलेक्ट्रिक यहाँ पे फिल कर दिया पूरा. ऑलराइट, the equivalent capacitance of the system will be, जैसे कि हम डिस्कस किए, these both will now look in parallel, right? इसको अगर देखा जाएगा तो this will be like this. यहाँ पे k है, यहाँ पे 1 है. तो हम ये भी सोचे कि एरिया अगर हाफ हो गया तो कैपेसिटेंस विल बिकम हाफ ऑफ इट. Capacitance final on the upper side, we'll call it C upper and C lower. So C upper will be epsilon naught into A by 2D, which is C by 2, and C lower will become K times epsilon naught A by 2D, which becomes KC by 2. So effective capacitance कितना हो गया? K plus 1 into C by 2, which is nothing but K plus 1 into epsilon naught A by 2D. Hence option A is perfectly correct. Next, the net charge flowing on the lower half of the plate is 1 by k times the charge flowing on the upper half of the plate. The net charge of lower half of the plate on the left hand is 1 by k times the charge on the upper hand of the plate, which is wrong because जहाँ पे डाइलेक्ट्रिक है वहाँ automatically charge k times q हो जाएगा. We already discussed when potential difference is maintained, the charge becomes k times. Getting it? So ये गलत है. Option A, net charges flow on lower and upper halves of the left hand plate are different. The lower half and upper half of the plate net charges flowing are different, which is correct because नीचे साइड में ज्यादा charges रहेंगे, ऊपर साइड में कम charges रहेंगे. And one more thing, net charge on the lower half of the plate will be equal to K epsilon naught A by 2 into V by D. So ये हम figure out करेंगे. We got the capacitance total, right? The capacitance of the lower part is Kc by 2. K into C by 2. तो कितना चार्ज फ्लो होगा? K into epsilon naught A D by 2. Not A, K by D, K by 2. This will be equal to the capacitance. This is given by charge by voltage. It's given by charge by voltage. अब चार्ज कितना हुआ? KV epsilon naught A by 2D, which is also the correct option, guys. So the answers are A, C, and D. This is a multiple choice question given to you by me. So that is about it for today, guys. So before we go, I like to thank all of you guys for being a great show. Good one. Anjali and Sim24, great job. It was great seeing you here. And see you in tomorrow's class again. Kal bhi same time 5:30 baje ko. Let's have the continuation of this, and tomorrow we will be discussing about multiple concept problems. We will be discussing multiple concept problems, and then we will be done with the chapter and we will start current electricity. So stay tuned, guys. And until next time, adios amigos.